Okay guys, this video is on zero and negative exponents, and I'm on page 88 in the book, so please follow along. Alright, so the notes were previously attached on the previous assignment. I hope you copied those into your math journal, and I'm just going to start doing some of the examples for you. So the first one says x to the fourth divided by x to the seventh. So what I'm going to do is I'm going to write this as a fraction because when you do, you're going to see that we might get a different answer writing it this way than we would have if we just thought in our heads doing it the other way. So what this problem looks like when I start to subtract those exponents, remember dividing bases, subtract exponents, it looks like x to the fourth minus 7. So whatever's on top is your first number and whatever's on the bottom is what you're subtracting. So make sure you get that straight so you don't make mistakes. All right, so now I have 4 minus 7. My signs are different, so I'm going to subtract. 7 minus 4 is 3, so I get x to the third, but the answer takes the sign of the bigger number. And since 7 is bigger and it's negative, that answer is going to be negative. Now, here's what we're learning today. I cannot end with a negative exponent. It's just not allowed in math. So what I have to do is make that exponent not negative anymore. And the way you do that is you write the reciprocal or the inverse of that exponent, and it just gets rid of the negative for you, okay? So what I'm going to do is I'm going to put a 1 on top and just move that whole x to the third to the bottom of my fraction. And that's how I get rid of the negative exponent. All right, let's do another one. Number 2 says b to the negative 5 times b to the 9th. And now I'm multiplying. So remember, when I multiply the bases, I add the exponents. So what this looks like, if I write it out, is b to the negative 5th plus 9. So I know that my base is going to be b. And now I'm just adding those numbers. Negative 5 plus 9. The signs are different, so I subtract. 9 minus 5 is 4. And the answer takes the sign of the bigger number, which is 9, and it's positive. So I'm going to leave that as b to the 4th power. All right. Let's do another one from this section because I feel like it's important for me to show you all these examples today. So I have w to the 5th and then all of that to the negative 4th. Okay, so again, when I have an exponent on an exponent, I multiply the exponents. So keep the w, and then negative 4 times 5 is going to be negative 20. But I can't end with a negative exponent. So I'm going to write the inverse, which gets rid of the negative for me. And then my answer becomes 1 over w to the 20th power. All right, let's keep going. All right, I think it is important for me to show you the next section, so I'm going to do that too. Okay, in the directions of this section, it says m equals negative 4 and n equals 5. And then my problem is m to the negative 2. So I'm just going to plug in m for m, plug in negative 4, and then I'm going to evaluate it, okay? So the only thing is I can't really evaluate it when I have a negative exponent. So I have to write the inverse first and get rid of that negative exponent, which gives me this number, okay? Now I can evaluate the bottom of it. Negative 4 squared is going to be a positive 16. And that's my answer. Let's do one more of these. Let's do number 7. It looks interesting. M to the 0 power, N to the negative 2 power. And I erased my M and M. M is negative 4, N is 5. Okay, so I'm just going to plug these in. And for M, I have negative 4 to the 0 power times 5 to the negative 2. Okay, so remember our 0 exponent rules. Anything to the 0 power always equals 1. Now I'm going to get the inverse of this next part. So technically I have 1 times. Okay, we're going to move on to scientific notation. So for scientific notation, remember if you start with a really large number, your exponent is going to be positive. And if you start with a really small number, meaning a decimal, your exponent's going to be negative. Okay? So the first one, I'm starting obviously with a very large number. So I know I'm going to have a positive exponent. And what I'm going to do is I'm going to take that decimal point, which is sitting right here, and I'm going to move it over until it's between my first two numbers that are not 0. So, and I'm going to count as I do it so I know what my exponent will be on the 10. 1, 2, 3, 4, 5, 6, 7. And I want that exponent to be right here because that's between my first two numbers that are not 0. So it's going to be to the 7th power, and it's going to be positive because it's a large number. And then I'm just going to write the numbers that are not 0 with that decimal place that I put in there. All right, if you forget the decimal place, you're going to be wrong. So please remember the decimal. Okay, let's do the next one. So the next one, I'm starting with a very small number, a decimal. So I'm going to have a negative exponent on my 10. That means I'm going to take this decimal here and I'm going to move it till it's between these two numbers that are not zeros. Okay? And then I'm going to count how many hops I made. 1, 2, 3. So it's going to be to the negative 3rd power. And then I'm just writing the numbers that are not 0 with my new decimal place. All right? Now, the next and last section for today is taking a number that's already in scientific notation and putting it back into standard form. Okay, last two problems. We can do it. So I am going to look first at my exponent and see if it's positive or negative, because if it's a positive exponent, I need to end up with a large number. If it's a negative exponent, I need to end up with a decimal. And that's the best way to know which way to move the decimal on these, okay? So I'm going to write 7 and 6 down, remembering that my decimal point is right there. And I'm going to move 8 places to the right because I want to make a bigger number. So 1, 2, 3, 4, 5, 6, 7, 8. And my new decimal will be there. And I'm going to fill in all these loops with zeros. Make sure there's only 1 0 in each loop. It matters how you line up the loops and the zeros. Okay? And then I'm just going to rewrite the number now with commas and without any of my decimals so I don't get confused. So 7, 6, 0, 0, 0, 0, 0, 0, 0. And every 3 numbers I put a comma. 1, 2, 3, comma, 1, 2, 3, comma. Okay? And I know I got the right answer because I have a positive exponent and I have a large number, which is exactly what I want. Okay, sorry, this is like my 5th video of the night and I think I'm losing my voice. All right, so the last one is 9.5 times 10 to the negative 3rd. Negative exponent means I'm going to have a small number or a decimal. So I'm going to write the 9.5 down, remembering where that decimal was, And I'm going to move that decimal 3 places to the left this time so that I can keep a small number. 1, 2, 3. My new decimal goes there. 1 0 in each little loop. And then I can also put a 0 on the front. And then I'm just going to rewrite it so it looks neat and not sloppy. So I have 0.0095. And I know I'm good because negative exponent, tiny number or decimal, and I moved it the decimal 3 places over from where it originally was. All right? All right. Let me know if you have any questions. Email me. I'll see you next time.